Before we begin our lesson today, I want you to think about something. Imagine that this preschooler here, Jeremy, came up to you and said, "My grandfather is really old. My grandfather is 1,500 years old." What would you think about this? How would you know that Jeremy is either mistaken or that he misspoke? You would know this because no one lives to be 1,000, right? In fact, if I were to ask you what the average life expectancy of someone living in America is, you would know that it's somewhere between 70 years and 100 years. Well, how do you know this? Average life expectancy is something called a statistic. Statistics can be all kinds of things. They can be things like the average person eats almost 1,500 pounds of food a year, or 50% of Americans fall asleep on their sides, or car airbags kill one person for every 22 lives they save. We won't go into the details of how exactly researchers gather and report this information fairly, but we are going to talk about averages. Do you want to know a fancy word for averages?
Central tendency. Now, why would something like this be important? What would we use it for? Things like weather, sunshine, rainfall in particular areas. That's really useful information for a farmer. And think back to what I said about car airbags. What if the statistics were reversed and airbags only saved one life for every 22 they killed? Would it make sense to have them? I don't think so. So statistics are what help us make sense of our world. It's the area of mathematics that we use to make sense of everything, to try and put order to things and make the most logical decisions. So central tendency, what exactly does this mean?
Tendency is an inclination toward a particular behavior, like I tend to go to bed at 10 o'clock every night, right? So when we're talking about information or sets of data, we want to know, how does the center of the data behave?
If you recall, a stem and leaf plot shows a set of numbers by organizing it in unique ways. Here, divided by a bar, we have the number 19. Where 1 sits in the tens place and 9 sits in the ones place. These numbers are all organized so that you can easily see that the 30s and 40s are where most of the numbers are centrally located. Similarly, you can see this pictograph also represents data. You can see that Dick has the least amount of toys and a kid named Bunty has the most. So sometimes we'll use stem and leaf plots or pictographs to talk about averages, but other times we don't have pictures to show us, we just have a set of numbers, where all we see are numbers for the data. Like here we have 2, 4, 7, 7, 10. It's not laid out in a stem and leaf plot or a pictograph, but we still have to kind of make sense of it. So let's talk about the definitions of the 3 different types of measures of central tendency: mean, median, and mode.
The mean is just the average of all the numbers. To calculate the mean, you need to add all the numbers together and then divide by however many numbers there are. You can remember this by, it's mean to call somebody average. The median is the middle number. So when you line up all the numbers from least to greatest, which one is in the middle? This is the median number. The mode is whichever number occurs most. The range is just the difference between the largest and the smallest number. So you take the largest number, you subtract the smallest number, and that will give you the range of the data, or the spread of the data.
Now, here's a rhyme you can use to remember the difference between these definitions. It goes like this. Hey diddle diddle, the median's in the middle. You have to add and divide for the mean. The mode's the one that appears the most, and the range is the difference in between.
Mode and median are pretty easy to understand, but what about mean? Why, when we add all the numbers together and divide by however many there are, do we get a number that represents the average of the whole set of numbers? Let's take a look at this concrete model. In this row I have 8 pieces of Life cereal. Here I have 4, 2, 6, 4, and 6. Now what happens if I were to add all these together into one big pot? Well, they would have the freedom to move around, wouldn't they? Move this down. Look at that. I didn't change the amount of life pieces that I had, but I did change how many are in each row. So now we have 5 life pieces in each row, which means that the average of 8, 4, 2, 6, 4, 6 is 5. Now let's check that with what we know. Let's add 8 plus 4 plus 2 plus 6 plus 4 plus 6. Well, I know 8 and 2 are 10. I know 4 and 6 are 10. And another 4 and 6 are 10. I have 10 plus 10 plus 10 equals 30. Well, 30 divided by, how many rows do I have? 1, 2, 3, 4, 5, 6 rows. 30 divided by 6 is 5.
So let's apply these new definitions to a set of data so we really understand what mean, median, and mode are. This set of data represents a family and the number of times they stub their toes on something in the living room.
Remember the rhyme? Hey diddle diddle, the median's in the middle. You have to add and divide for the mean. The mode is the one that appears the most, and the range is the difference in between.
So first, let's take the mean of all these numbers. Remember, it's mean to call somebody average, so what we want is the average of these numbers. If you recall, to find an average of a set of numbers, you need to add all the numbers together, 2 plus 4 plus 7 plus 7 plus 10, and then you need to divide by however many numbers there are. Well, we can see here that there are 1, 2, 3, 4, 5 numbers. 2 plus 4 plus 7 plus 7 plus 10 is 30. Thirty divided by 5 is 6. So we know that the mean of this set of data is 6. This family stubs their toe a mean of 6 times per day. Alright, now we're going to calculate the median of this set of numbers. Remember, median means middle. Lucky for us, these numbers are already ordered from least to greatest. So all we need to do next is locate the middle number. Since there are 5 numbers here, we will have exactly one middle number. We can take off the 2, we can take off the 4, we can take off this top number and that next number in order to see that the middle number is 7. The median for this set of data is 7. Now let's find the mode. Remember, mode means most. Can you see which number here occurs most? It's very easy to see that 7 occurs twice, but every other number only occurs once. Therefore, the mode is 7. Now let's find the range for this set of data. Remember, the range is just the largest number subtracted by the smallest number, the difference between the two. So here we have 10 minus 2. Well, that equals 8. The range for this set of data is 8. So we're evaluating these measures of central tendency. For the family that stubs their toe in the living room 2, 4, 7, 7, and 10 times. They stub their toe about an average of 6 or 7 times. The exact average, or the mean, is 6. The median is 7, and the mode is 7. The range for our set of data is 8. The mean, median, and mode are relatively the same, but this won't always be the case. In fact, sometimes they can be quite different.
Data sets can be all kinds of things. This data set shows the average points scored by LeBron James in his first 7 seasons in the NBA.
They're about middle of the pack defensively. Oh, a nice fadeaway by LeBron James. So, here's James. The stuff. He hammered it down.
Now, if someone were to ask you to find the median of these numbers, would you say 27? No, because these numbers aren't in order yet. 21, 27, 31, 27. You have to first order them from least to greatest. Now that we have them ordered from least to greatest, can you see where the median is? Clearly, in this set of 7 numbers, the median is 28. And what about the mode? Are there any numbers in this data set that occur more than all the other numbers? Bingo! 27 occurs twice, while every other number only occurs once, so 27 is the mode. What about mean? How do we find mean? Step 1, add up all the numbers. 21 plus 27 plus 27 plus 28 plus 29 plus 30 plus 31 is 193. Step 2, divide. But how many numbers do I have to divide by? 1, 2, 3, 4, 5, 6, 7. There are 7 numbers in our data set. So 193 divided by 7, 27.571. Finally, what about the range? Remember, range covers the whole set of data from least to greatest. So 31 minus 21 is 10. The range is 10.
You want more examples? You betcha. Let's look at the number of pets in houses on Main Street. So it looks like somebody did a survey of everyone who lived on Main Street and asked them how many pets they had in their house.
Ugh, I only have 2 dogs, but my neighbor has 45. I also have 2 pet dragons, but the researchers said they weren't real.
Now it's easy to see that the first order of business here is to get these numbers in numerical order. Shall we repeat our rhyme? Hey diddle diddle, the median's in the middle. you have to add and divide for the mean. The mode is the one that appears the most, and the range is the difference in between. So this data set has an even amount of numbers, so there's not a clear median. What you have to do is find the middle, so we see that 3 and 4 both share the middle. So we take the average of those numbers. Remember, to take the average or the mean, you have to add and then divide. Add 3 and 4 together, you get 7. Divide them by however many there are 2, and you get 3.5. So the median is 3.5 animals per house. Remember, mode means most. Here, on Main Street, it looks like the mode number of animals per household is just 1. And what about mean? After we add all the numbers together, we get the number 71, divided by 8, and we get the mean of 8.875, which rounds to 8.88 animals per household on Main Street. And for the range, we take 45 minus 1 and get 44.
So, what did we learn today? We learned that the measures of central tendency is just a fancy way of saying average. And averages are useful for all kinds of things. Athletes use averages, students use averages, even farmers. We also learned that it's mean to call somebody average. We learned that mode means most and median means middle.
Let's sing our rhyme again. Hey diddle diddle, the median's in the middle. You have to add and divide for the mean. The mode is the one that appears the most, and the range is the difference in between.
Just remember, guys, math